So hello everyone and welcome back to Aayu Pathshala. In this computer network video series, we are dealing with the data link layer, and in the previous video, we have discussed the two major responsibility of the data link layer, that is the error control mechanism and flow control mechanism. And we have already seen the framing as well as the physical addressing. So in this video today, we will be discussing about the media access control mechanism of the data link layer. But before that, this is the channel. If you have not yet subscribed to it, kindly subscribe, Aayu Pathshala, and I'll be uploading the notes of this lecture on this Telegram channel t.me apdciu 2025. Now, before we go to see the different mechanism of the data link layer, let us understand why do we require the media access control. So, this is the data link layer, and after that is the physical layer. So, this is a physical medium through which the bits are transmitted by encoding it into signals. Okay, and here also we have what data link layer. So, there could be different devices. Let's say suppose D1, D2, D3, and there could be different devices over here. And this way we are sending, and this here we are receiving. So for example, let D1, D2, and D3 with the three devices, and each devices is now having data at its data link layer for transmission to the physical layer. Okay. Now, since there are large number of devices, I have taken only three devices. It could be a possibility that two or more devices wanted to send the data simultaneously at the same time. For example, at time t is equal to 0, D3 wanted to send the data. It said, okay, I will send the data. So the D3 will send the data. Obviously, let's say the first bit it transmitted is 0. Okay, so corresponding to it, the signal will be this, a flat line with low amplitude. Similarly, at the same time, D2 also want to transmit the data. So at time t equal to 0, D2 also transmitted the data, and its first bit it transmitted was 1. So this 1 is represented by 5 volt. Now these two signals, because they were simultaneously transmitted at time t is equal to 0, will combine to form an overall signal of one signal, that of 5 volt. So that this result in the loss of the data being sent by D3, because D3 sent what? 0, but it is only the resultant signal is representing only 1. So that may be a possible scenario. To avoid this, we need to develop a mechanism so that there could be a mechanism which can implement the control of the media access. This is the media through which we are sending the data or the bits. So the control of which device will have the access, and the device who will have the access will transmit. Other device will wait. So this is known as the media access control, and we have understood why we require this media access control. So there could be different algorithm or different techniques through which a media access control can be implemented, and it could be broadly categorized into like random access control, and one is the random access control, and another is like in which there is no random access. There is like the proper controlling of the media access. Random. What do you mean by the random access? Random access means कि randomly anybody could access. And in the controlled access, there is another method known as the controlled access control, in which no random device can access the media. They will either do it in a controlled fashion. So let us first discuss the Aloha protocol. Aloha, or also known as the plain Aloha protocol. So up till now, we have understood what is the transmission time and what is the propagation delay, TT and TD. We have understood this thing. So let us introduce a new concept over here, which is known as the vulnerable time. Okay, what is vulnerable time? See, this is, suppose the length between two devices. Say this is TP is the propagation delay, and this is one frame which is being transmitted. Suppose here there is another device connected, T2, which is, let's say, after length L2, and this is D1, which is at the starting of this media access or this channel. There is another device, D3, which is located at here, and everybody want to send this data to this receiver. So obviously, D3 will be required to travel less distance. D2 is a little longer than D3, and for D1, the propagation delay will be larger because the distance the bits has to travel to reach to RX is more. So once first D3, D1, when D1 is transmitting, it will have to transmit its entire frame. So when this frame is getting transmitted, so D2 must be able to identify that this frame is getting transmitted, and it should not transmit this frame when the transmission is going on. That means if TT is the time for the frame transmission of D1, okay, so what could be the vulnerable time? Vulnerable time means the time duration during which if any other device started transmitting would result in collision. Okay, like the time interval during which if any other device also start transmitting through the same media could result into collision. Okay, so this vulnerable time can be, since D2 should not be transmitting the signal for any time interval t minus tt and also t plus tt. That means for now transmission is started at time t equal to 0. So unless the transmission completes, no device should start transmitting. Also, like suppose if D2 is transmitting, like let's say the transmission time is 6 seconds, and let's say the transmission started at t is equal to 2 seconds. So if this D1 is starting transmission at time t equal to 2 seconds, that means 6 seconds before time t equal to 2 and 6 seconds after time t equal to 2, there should not be any transmission. For example, let's say if D2 started transmission, or to understand it better, let us say that this is t is equal to 10 seconds per start here. Okay. So if t is equal to 10 seconds and D2 will start transmitting at t is equal to say 9 seconds, then obviously it will collide with this frame, because this at t is equal to 10 seconds, it is starting sending this frame. Okay, and if D2 is sending this frame and say that length requirement is 6 seconds only, so this at t equal to 9 seconds, it will start transmitting the frame, and this frame transmission will complete after how much time? After 6 seconds, that is 15 seconds. But at time t equal to 10 seconds, D1 is also transmitting the frame, so there could be collision. That means not the D2 should not transmit TT's timing this second before the transmission of the frame and also after the transmission of the frame. Clear? Not suppose that at t equal to 10 second transmission is started. If D2 started transmitting at t is equal to 15 second, at that time, what would be the time required for the completion of the transmission? That will be equal to t equal to 16 second, because 6 second is the transmission time. But at t equal to 15 second, D2 start transmission. So there would be a collision, both the devices transmitting at the same time. So to avoid this, we must ensure that D2 must not transmit for t second before the transmission time, and for t plus tt. That means we can say that vulnerable time would be twice of transmission time. That is transmission time, not even before the transmission and not even after the transmission, that both the time has to be included. You getting the point what I want to make over here? So the vulnerable time for Aloha protocol will be 2T, 2 of transmission time. Okay. I hope you understand that. So now, because any device is free to transmit data anytime, so we have to make ensure that if any device is transmitting data at any time, so vulnerable time will be 2TT. Now, this is the vulnerable time. Then there is the formula of throughput, which is given by S max, which is known as throughput. What does it mean? I will explain you. And this is given as G into e to power minus 2G. Just remember this formula, very important from the examination point of view. Questions is asked from this formula directly. So what is G? G is nothing but it is the number of average number of frame generated by system during one frame transmission time. How many frames a system is generating? For example, in ideal case, there should be one frame. If there is a one frame, then that means only one frame is generated in one frame transmission time. There could be like no collision. But if there are a large number of frames generated within the transmission time, then there could be a collision. So for G equal to cancel this out, like e to the power minus 2G, if we like put G equal to 1 by 2, then this max could be 1 by 2 into e to the power minus 1 or 1 upon 2e, and this is nothing but 0.184, and this is called the maximum S. Maximum S is achieved when G is 1 by 2, or we can say that the maximum throughput of this Aloha protocol is 18.4%. Now you see, what does it mean? It means that, for example, if you transmit 100 frames, if you transmit 100 frames within one frame time, then what would be the total number of frames that could be reliably transmitted? That is with throughput, that is only 18.4 frames, or we can say 18 frames. So out of 100 frames, only 18 frames are able to reach to the receiver, and remaining of the frames. Now, when I talk about frames, you must understand what is a frame is. It is a combination of bits. We have seen this in previous video. So we say that out of the 100 frames, only 18 are reaching. That means almost 82 frames are discarded, and that is a very high loss. So therefore, we need to modify the Aloha protocol, and how the modification could be done. Like, see, in the simple Aloha or plain Aloha, what we have that there is no time slot or nothing is defined for the sender. Any sender, like any device, is it can send at any time. Can send at any time. So therefore, vulnerability was twice of TT, because it has to ensure that T seconds before the transmission and T second after the transmission, that is the TT second, that is the transmission time, the device should not transmit in order to avoid the collision. But in this, if we ensure that each device will only transmit after transmission time T slot, if the device will only transmit after the transmission time T slot, like suppose device will start transmission at time t equal to 0. If any device is not ready at that time, then second time slot will be available at 0 plus tt. Okay. So when 0 plus tt time, when 0 plus tt time, that means between these two timing, there is no slot available and device will not be able to transmit. So if any device will become ready at 0.05 transmission time, it cannot start transmission. It will have to wait for the next slot to begin. And when will the next slot begin? It will become at 0 plus TT time. So we divide the times into slot and we say that each device can send or transmit only at the beginning of the time slot. The next slot would come at 0 plus 2 transmission time, 2 TT. Now, if the device misses this slot, it cannot randomly start transmitting between these two time slot. It will only start transmission at 0 plus 2 twice of transmission time slot. So in this way, we are actually avoiding that head-to-head collision. We are avoiding head-to-head collision. How? See, now the before one, that is any device now start transmitting, cannot start transmission at this time. That is, for say example, transmission times, a device started transmitting time t equal to 10 and transmission time is tt is 5 seconds. So there could be a device which will only transmit at time t equal to 15 or time t equal to 20. But in the previous case, we have a device can start transmitting at time t equal to 16 seconds. So when a device will start transmitting at time t equal to 16 seconds, there is a possibility that it will collide with device which started transmitting time t equal to 15 seconds because it will continue transmission till 20 seconds. And also the device which is transmitting at 20 seconds, it will continue up to what? 25 seconds. And this 16-second device will now continue transmitting up to 6 plus 16 plus 5, that is equal to 21 seconds. So it will collide both one frame which started before it and one frame which started transmission after it. Therefore, there was 2 TT transmission time. But here, this before one, it cannot like transmit at time t equal to 16 seconds. So it cannot collide with the frame which is started before it. It will only start transmission at time t equal to 20 seconds. Now, there is only one possibility here that two or more than two device will start transmission during the same time slot. There could be, this is the possibility. So here vulnerable timing, can we say that is only transmission time. There is no transmission time, but only to transmission time. So in in the aloha in the aloha protocol, we have two types of collision, that is head-head collision and head-tail collision. That is one when started simultaneously transmission and one before and after. Head-head collision and head-tail collision was possible. Okay. In Sloha protocol, matlab Aloha, slotted Aloha protocol. Now say, whether head-tail collision will be possible? No. Only head-head collision will be possible when two or more devices started transmission at the same time or at the same time slot. So in the slotted aloha, head-head collision is possible. But in the simple aloha or a plain aloha, there is two types of collision: head-head collision and head-tail collision. And therefore, vulnerable time was twice of TT. And here, vulnerable time is only TT. Okay. So this technique is called as the slotted aloha. And in slotted aloha, we have like vulnerable timing is only TT. Now, since when vulnerable time is decreased by 2, by a factor of 2, we can say that the throughput or S max will increase by the same factor. So it is given by G into e raised to the power minus G that we have given. And now for G equal to 1, we have as e raised to the power minus 1, that is given as 0.368. See, here it was 2G, here it is only G. So in the slotted aloha, we are having throughput as twice of the, that means twice of the plain aloha. Plain aloha. Okay. So we've increased the throughput. That means now if 100 frames were transmitted, out of which 36.8 frame will easily reach to the destination. Previously it was only 18 frame. Okay. So this is slotted aloha. I hope you understand the difference between the aloha and the slotted aloha. Now if you want like to note this down, you can note this down, or otherwise we are having notes also. We will discuss the notes at the end. Now, there could be also, these are two techniques. There could be the third technique, which is known as CSMA. And what is CSMA? See, it is called carrier sense multiple access. Carrier sense multiple access. Now, carrier is sensed. So, if carrier is sensed, we must say that the this type of protocol is only possible in wire technique because carrier could be sent on when the signal travels on the wire. So in the carrier sense multiple access, what is required that each station that wants to transmit the data will have to first listen to the medium or check the state of the medium before sending. So like it cannot totally avoid the possibility of collision, but means it cannot eliminate collision. I mean the collision will happen, but the probability it will reduce the probability of collision. Okay. So there might be a collision, so it is collision avoidance. Okay. Like it cannot eliminate it, it tries to avoid it. So this technique is known as the CSMA, carrier sense multiple access. Now here, see how long this is the medium. So how long will it have to sense for the entire TP time? For entire the propagation time, it has to monitor the carrier. So vulnerable time here will be TP. So as long as the propagation is taking place, it should sense that no other device should be starting transmission. So vulnerable time here will be VTP. Now see how does it see? How does this actually work? Let's say suppose this is a device which wanted to send a message or transmission of the bits. So it will first sense the channel. Let's suppose it will first, this is how the algorithm works. It first suppose the channel. If it is free, then it start transmission. If it is not free, if it is busy, now here you again keep on continuously sensing the channel. Like if somebody else is transmitting, obviously it will be busy. So if this is busy, you keep on sensing it. As long as it is busy, you keep on monitoring the channel. So once the once this transmission is finished and it is free, now you start immediately sending it. This is what called as the carrier sense multiple access. And it could be of like two type, persistent, persistent and non-persistent. What do you mean by persistent? Persistent means you are continuously sensing this channel. That means you are wasting too much of resource, not in transmission, but in continuously sensing the channel. Non-persistent, the basic concept is the same. However, before like before again sensing the channel, if it will start sense the channel, if it is free, it will transmit. If it is busy, it will not continuously sense it. It will like wait for some time. It will wait for some random time and then it will start sensing. This is called non-persistence. For example, this is a general logic. See, if somebody is transmitting data on the channel, then obviously it will not immediately like if it start transmission at time t equal to 1 second. So immediately it is worthless to check after t equal to 2 second. Why? Because the transmission would not complete immediately. So if somebody is transmitting the data, obviously it will take some time. So you take some you don't know whether it has started you if you start sending like sensing a time t equal to 1 second, so you don't know whether the transmission is started exactly at t is equal to 1 second or it was started 4 seconds before and it is about to finish after some second, or you don't know the actual scenario, so you randomly allot some time. It may be greater than the transmission time or propagation time or less than the propagation time, and for that time you stop sensing the carrier. Okay, you assume that so say suppose after 4 seconds, for example, randomly I take a time of 4 seconds. Say I said that 4 seconds, let me check after 4 seconds. You start sensing it, you again after 4 seconds, if again it is busy, you again increase the time from the previous time, like 4 seconds to 6 seconds. You said, okay, after 4 seconds I have sensed it is still busy, let me wait for some more time. You will wait for 6 seconds and check. So this process will continue, and this technique is known as CSMA non-persistent technique. Okay. Now there could be another technique also where not only avoidance of collision is required, but also we need to detect whether the collision has happened or not. So, like it would be like this technique is known as the carrier sense multiple access with collision detection, CSMA CD. So here for detection of the collision, we must have the transmission time TT is nothing but twice into the propagation time TP. This is the condition that you have to transmit for a longer duration. If the transmission continues for twice the propagation time, then and if there is a collision, then this would be the scenario. For collision detection, transmission time should be twice of the propagation time. And we know that this is given by nothing but length of the frame upon bandwidth, and this is given by nothing but the distance between the two devices upon the propagation speed. We have already seen this relation. Just remember this relation that the for CSMSCD, this is the condition which is required for the collision detection. Transmission time is twice of the propagation time. We have, in terms of the throughput, it is obvious that the throughput of the CSMA and CSMACD will be greater than Aloha and slotted Aloha. Aloha and slotted Aloha. So for Aloha, we have 0.184. For slotted Aloha, it was 0.36. Now for CSMACA, like there could be persistent and non-persistent. For persistent, we have 50% throughput, and that is for G equal to 1. Here we have G equal to 1 by 2, and we know already what is G. It is the average number of frame that is transmitted in one transmission time. For also G equal to 1, we have 50%, and for non-persistent, we have throughput as up to 90%, and that is achieved for G equal to 3 and G equal to 8. Just remember these things. Okay. This is the throughput for Aloha that we have discussed already for slotted Aloha. This is the throughput in case of CSMA CA, and that is for G equal to 1. And for non-persistence, we have 90% for G equal to 3 and G equal to 8. So this was the like random access protocol. Then there could be the controlled access protocol also. Controlled access protocol. In the control access protocol, we have different technique. One is called the reservation. So what do you mean by the reservation? See, each station need to make reservation before sending the data frame. Like for n station, we will have like if there are n station, we will have n reservation mini slot. N slot will be there. So in there would be a reservation frame, and there would be n mini slot for reservation, and reservation frame is followed by the data frame. So first of all, a reservation frame will go, each channel will make reservation. Okay, I will send, I will send, I will send. Accordingly, the priority in which the reservation is set, the each frame, each channel will or each device will send the data frame. So first the reservation frame will come, then the data frame will come. Other technique could be like polling. So before polling, there is a similar technique to reservation that is called as the token passing. And we are very much familiar about this. What happens? In token passing, there is a token, or we can say this is the authority slip known as the token. The device which currently has the access to this slip will only transmit. Other device will have to wait. So sequentially, what it will do, there are a large number of devices who want to transmit the data. Okay, this suppose this is the token slip. So this device has the access to the token slip. It will send its data, and it will move forward this slip to forward the next device. If this device want to send the data, it will keep the slip and start transmission. If it does not want to send the data, it will forward the slip to the next device. Similarly, if this device want to send the data, it will start transmission. If it does not want to send the data, it will directly forward the slip to the next device or token to the next device. And in case if it want to transmit the data, then after completion of the transmission, it will transmit the data to the next device. So in this case, we are controlled access where there is no collision because the device only transmit the data when it has the access of transmission. Here also reservation. The transmission of the data is basically taking place when according to the reservation or priority of the reservation done in the reservation frame. So the next technique is called as the pooling. So it is basically working in those topologies whereas one device is designated as the master or the primary device and other as the secondary device. So there will be large number of devices who want to send the data through the medium. So out of them, one device will act as a master device, and it will say, okay, it will have all the details of this device, and it will say, okay, you want to send the data, send it to me. I will send it to the carrier. Or all those who want to send the data, forward it to me instead of sending it to the directly through the medium. You send it to me. Though all device will send the data to it, and it will start transmission one by one through the medium. Similarly, if there is a data for the receiver end, it will receive the data and it will check which device the data has to be forwarded, and it will forward it. Okay, so there are two methods that are being used by this master device, and that is known as the two function. One is called the pole function. One is called the pole function. Another is called the select function. What is the pole function? Like if primary want to receive the data, it acts as a secondary device if they have data to send. That means if this is a device, it has the data to be sent. It will give chance to each of the device. It will pool among the device. Those who want to send it that data, it will ask them to send it, and then it will forward to the medium. Select function, whenever like the primary device want to send the data to the secondary device, that is while receiving data, when it will receive data. So when it will receive data, it want to send it to the secondary devices. So it will tell the secondary device to get ready to receive the data, and this is known as the select function. Okay. So we have understood what is the polling. There is a primary device and a secondary device concept in which the secondary device is responsible for the data access of the medium. Not all the device access the medium. Only one device access the medium. That is the primary device. And the secondary device will send the data through the primary device. It performs two functions. One is called the polling function. Another is called the select function. So another technique that we can use in the control access protocol is the channelization. So now what is channelization? This concept already we have discussed in the communication topic, wherein we have seen that the channel can be utilized. Suppose this is the medium, so it has bandwidth ranging from f0, say f1, all the different frequencies are there. So we can effectively use these frequencies or different lanes to send the data. Okay, so there could be different techniques, like we have seen the FDM, frequency division multiple access. There could be time division multiple access, or there could be code division multiple access. In frequency division multiple access, we have discussed this that the single frequencies, different frequencies, the data has been transmitted at different frequencies. So accordingly, there is no interference if two data is being transmitted at different frequencies. In time division is we have seen that the time of transmission is basically divided into different techniques. We will discuss this technique separately. Okay. And in code division multiple access, we have the different codes which are basically orthogonal codes which are used for the transmission. So this FDMA, TDMA, and CDMA we will discuss. So this comes under channelization. So under controlled access protocol, we have seen four technique. One is called the reservation. We have seen what is reservation is. Then another we have seen is token passing. So if in question it comes that this is either the random access protocol or a control access protocol, so you should be able to answer now that these are the control access protocol. Then after that we have polling, and two main function performed by the primary device are poll function and the select function, and we have the channelization. So now let us go quickly and see what are there in the nodes. So here we have the media access control. So in the media access control, it decides who gets to use the channel in shared networks, Ethernet, Wi-Fi, and the protocols are Aloha. That is the random protocol, and collision is possible. Aloha efficiency is 18% and slotted Aloha efficiency is 36% that we have seen. Then CSMA, carrier sends multiple access. That is, you have to sense the carrier before you transmit, and there could be two variants in it. Number one is CSMA CD, and number two is CSMA CA. One is the collision avoidance, another is the collision detections. Now, see, in collision avoidance, I've told you that collision detection, for to detect the collision, there would be a wired medium to detect it. How you will detect in the wired medium, and avoidance can be done in the wired medium or in the wireless medium. So if you talk about the analogy, see, Aloha is like certain students shouting answers randomly in class, that there would be a chaos. And we have seen, therefore, if 100 students are shouting, only 18 students' message could be deciphered. In CSMSCD, like student listen first. If two still speaks at once, they both stop and retry. That is what we do in CSMSCD. In CSMSCA, student raise hands before speaking, and then for we have the fewer collision. And we've already seen that here it is vulnerable timing is we have in CSMSCD it is twice of TP. Here we have TP, and in Aloha and slotted Aloha we have twice of transmission time in Aloha and transmission time in slotted Aloha. So if we just go for the quick recap, we'll find that we have seen framing, that is bits, frames, then error detection, simple parity check, checksum, CRC, we have seen that. Error correction, we have seen by hummingbirds. Then flow control, we have seen stop and wait, sliding window, automatic repeat request to go back in, and selective repeat, automatic repeat request. And for the media access control, we have seen Aloha, CSMA CD, and CSMA CA. So this completes the DLL. So this is all with this video. In the next video, we'll begin with the network layer. Thank you.